Hi friends, welcome to my channel AI Competitions. The main aim of this channel is to solve ongoing machine learning and data science competition and provide you the base solutions to start with. So if you are watching this channel first time, please subscribe to this channel and like this video. In this video, we are going to solve one of the ongoing competition in Kaggle, linking writing process to writing quality. Use typing behavior to predict SI quality. Okay, the goal of this competition is to predict overall writing quality. Does typing behavior affects the outcome of SI? We will develop a model trained on large data set of keystrokes logs that have capture writing process features. Okay, the main aim of this competition is to predict the quality of SI based on their writing process. So you can read description about the competition hosts, and also you can see the evaluation matrix they are using. They are using root mean squared error to calculate the evaluations. So here you can see the sample submission file. For each ID we need to predict the score of. So here the score is the quality of that SI. Okay, this competition timelines, you can see it started on October 2nd and it will end on January 2nd. Okay, if you see the prize money, so in first place they are providing $12,000, and in second place they are providing $8,000, and third place they are providing $5,000 for the winners. So, and also if you see the code requirements, this is the code competition. So in this competition we need to submit our solution through the notebooks only, using Kaggle notebooks. So next we'll go to the data description. So the goal of this competition is to predict SI quality based on their typing. Okay, while they are typing the SI, so they are giving SI typing features like SI typing features. So we need to, based on those features, we need to develop machine learning models to predict SI scores. They are provided trainlogs.csv. Okay, in trainlog.csv they are providing ID, event ID, downtime, uptime, action time, activity. Okay, and also down event, up event, text change, cursor positions, and word count. Okay, so in test logs.csv they are providing some examples to illustrate the format, how the format looks like. In train scores.csv, in each ID, unique ID, they are providing the corresponding SI scores. Okay, and also sample, if you see the sample.submission file, they are providing samples.submission file. So if here you can see the sample submission.csv. So for each unique ID we have to predict the scores of that SI. Okay, if you go to the trainlogs.csv, here they are providing ID, event ID, downtime, those features. Based on those features we need to predict the course of that SI. And also here you can see the discussions. Okay, so if you have any questions regarding the competition, and also you have some doubts about your model development or something, so you can post here. And also here you can see the leaderboard. There are 3 main medals, so gold, silver, and bronze. So I recently submitted one base solution to this competition, so I got 70th position. So I will provide that base solution in this video. Okay, we'll get started. So here you can see the publicly available notebooks, other shared. So if you want to get started with, just click on the new notebook. So it will launch new notebook in Kaggle notebooks. This is like your Jupyter environment, and also if you use Google Colab previously, this is similar like to the Google Colab. And okay, first we need to start this notebook. Just click on here. So it will assign one Jupyter server for you. So once it's assigned, so you can rename your notebook here. I'm renaming this as a writing quality baseline. Okay, first we need to import some required packages. So first we'll import imports. Okay, this is not required, so we'll drop that one. So I already have that code to import, so this is the imports we are doing. So next we'll load the data. Here if you click here, you can see the competition data. Here is the data. So if you want to load this one, so I already have the code for that, so I will directly load from here. Here I'm loading train logs, train score and test logs and sample submission file as a SSDF. Okay, so if you want this path, so directly copy whatever you want to load, you can directly copy that path. So here I'm copying that path and pasting here, so that file you can access. So once the data is loaded, you can check the shapes of each data frame. Here you can see the train logs shape. It's having around 8 million rows. If you see the train scores, it's having 2.5k rows. And also if you see the test logs, it's having only the 6. So in test logs, they provided the sample set of test data. Okay, when we are submitting to the competition, right, it will take whole test data to run and predict while we are submitting to the competition. We'll see how it's going further. Okay, so if you see the sample submission, for sample submission they have provided 3 rows. We'll see the train logs first. So here you can see the train logs. In train logs they are provided ID, event ID, downtime, uptime, action time and also activity. What are the activity, and also down event, up event, text change, cursor position and word count. So this is the training data they are provided. Okay, if you see the train scores, so in train score for each ID, so here we have the ID, right? For each ID they are provided scores. Okay, for example this is the train scores. So for each ID they provided the scores. So if you see the one ID in train logs, so for example I want to check one ID how the data looks like. So I filter out ID based on ID and equal to ID, and what are first we'll select one ID here, filter the one ID. Here you can observe that for each ID, so here ID is the SI writing and also event ID they provided. So while writing the SI, what are the events that happened? Okay, and also for each event ID they provided the features, that event features, downtime, uptime, action time and so on. Here we have unique IDs for each SI. In each ID we have multiple events. Okay, so here the events are represented based on the event ID. So they are provide you the sequence of IDs 1 2 3 4, that event IDs. Okay, for each event what are the features, corresponding features they provided. Okay, but at the end we need to predict for ID level. Okay, for each SI what is the scores. So we need to somehow aggregate this event features and given to the ID, and we'll pass to the model and train the model to get this ID level features. We'll see how we'll go to that one. So first we'll see how the target distribution looks like. For example, I'm using describe the scores. So here you can see minimum score 0.5 and maximum score is like 6. Okay, we have the target distribution. Now we'll do some EDA on the training data they are provided. So we'll get how the data looks like, right? So first we'll plot. So here I'm taking scores and plotting the histogram how the scores distribution looks like. Most of the scores are distributed in between 3 to 4 scores, and very less, right, 1 or 2 are in left side, and if you see in 6 scores are very less compared to the 4 to 5. Okay, so this is like left skewed distribution. We'll see the value counts, we'll apply value counts. So this is like you can see 0.5s. okay, they are provided scores in 0.5s. so most of the scores provided as a 4, 3.5, 4.5, in between 3 to 5. Next we'll see for each id how many events are there. If you apply group by id, you can get counts of that particular event. So I am doing the plotting here, so we'll get how the distributions likes. Maximum events we have for one particular id is like 12k events we have. So minimum we have something like 200 or something. So most of the distributions are coming from around 2k to 6k in between roughly, right? So if you observe the box plot also, the median in between around 3k or something events. Okay, so we'll do describe on this, and we'll understand how the describe is looks like. Okay, so minimum events for each id we have like 262, and maximum we have 12k, and median we have around 3k. okay, whatever we observed here we are representing in numbers. okay, for example, we'll see whether this events, long events, affecting our scores or not. okay, so for that I have one code, so we'll run that code. so here you can, if you run this code, right, I'm taking each event. okay, so here you can see number of events are increasing, that means your score also increasing. okay, if your events are very high, so for while you are writing summary, right, if you writing long summary, right, you will get more scores. Chances of getting more scores are very high. That all depending on your quality of summary writing, but in general we'll get this correlation between number of events and scores. And also we'll try to check uptime minus downtime equal to action time or not. Exactly true for all the rows they provided. If you see the train logs df, right, here we have id, event id, downtime, all those features, but we don't have the scores provided for this. They provided in another data frame called train scores, right? So this is the train scores, so we have to merge those two data frames to explore our data analysis. So here I am merging train scores to train logs. so here if you see the train log scores df.head, here I'm merging based on the id. okay, so here you can see the scores for each id they provided. so here based on the event ids it's repeating. okay, we have to somehow aggregate this event id column, so we can get for each id to get the score, corresponding scores. First we need to identify what are the numerical columns. so we already know the numerical columns, so just I am creating aggregation function on top of it. For example, here we have the train log score df. I'm grouping based on id, and I'm computing mean for all the numerical features available. okay, those are the numerical features, so I'm computing mean based on the id. we have unique value, right? so computing the mean and resetting the index. so if you see the train logs aggregation df, so now we have id values for 2.5k around data points, and each data point we created aggregation features for the numerical features. so here we have the downtime mean, uptime mean, action time mean, cursor position mean, and word count mean. So corresponding scores we have in that. Okay, this is the final data frame we can think, but we can create more features based on that. Okay, first we'll explore how the distribution is looks like. So here one function I am using. So for each numerical feature you will get the distribution plots. Okay, if you run this function, right, for distribution plots we can get for the each feature. Most of the downtimes are in between 0 to 2, and here you can observe the downtime versus the score scatter plot. Here you can observe the box plot and CDF cumulative distributions. Okay, so this is the uptime also in between 0 to 2, most of the distribution, and also the not much relation between the uptime versus the score. And also here you can see the action time in between 0 to 200. Here also you can see the action time versus the score scatter plot. Okay, so here the cursor positions, this is like right skewed distribution, and also here you can see the cursor position. Okay, if there are some correlation here, so if the cursor position are increasing, so your score also increasing here, somehow correlating between the cursor and the score we have. And also word count, so you see the word count distribution, and also your word counts are increasing, your scores are also increasing somehow. Okay, you can do some exploratory data analysis like this. Okay, so if you see the train logs, there are some categorical features also. We have activity, down event, up event, and the text changes. We'll see how those looks like, what are the activities we are having in train logs. So most of the activities we are having input, remove or cut, non-production, replace, paste. Those are the most common events activities we have. Next we'll see the down events. What are the down events they are provided? So they are provided around 131 down events. So most of the down events are Q space, backspace, shift, arrow right, something like that, they are provided. Okay, and also we'll see the up event, what are the up events we have, and also we'll see the what are the text change they are provided. So this is the text change they are provided. There are some anonymized values they are provided. We'll see how to handle those. Okay, next we'll create future engineering. Before we passing our features to the model, right, we have to create some features based on the ID level for grouping events. So we'll create some features. Here I'm using the publicly available features, okay, function. So what this function will do, like from activities, event, text change, punctuations, based on that events, what are the most frequent events we extracted and save it as this one. So and also we are providing the gap to create gap features. So here we mention some features to create from this events. Okay, so those are the functions. If you go to those functions, you can easily understand what are the features they are created. Okay, so this is the main function. So here we are creating time data features and also cursor position data features, and here you can see the word count data features, and here the some statistical features based on the event ID, uptime, action time, something like that. Based on those numerical features, we are assigning what are the features we need an aggregation level. So this function is going to provide you the aggregation level features, and at the end we are concatenating all the events and features what we are created. And also here you can see some, we are creating some ratio features based on the aggregation levels. To run that function, right, we have to run this code. So we are initializing that, and we are running the make features function for the train features and the test features. Okay, here we are saving train features and test features. So based on the gap, right, we are creating those features. Okay, once your features are created, this function will run for train and test data also. So it will create similar features for training and testing. Okay, we'll see how training data looks like once the features are created. So we are created features and save it in the train features data frame. So here is the train features data frame. So it's containing around 2.4k rows, and for each id we created features. So event id max, uptime max, action times, something like. We created all aggregation features, and here you can see the event. For events we are created unique features or something like that. So here you can see we created this many features. So if you check the train features dot shape, right, so here you can see the train features dot shape. For each id they provided, we created 230 features. Same you can check for the test data. So here they are provided sample test data, right. For 3 IDs we have, we have created those features. 230 features are the public features. We will try to create more features. So we have the numerical columns, right. Those are the numerical columns. Based on that numerical columns, so here I am taking the train logs and group by ID. For each ID, for those are the, we are mentioning those are the numerical features, right. Those are the numerical features, and we are aggregating, and here we are passing the aggregation functions. What are the aggregation we need? Mean, standard deviation, minimum, maximum, last, first, sim, median, sum. So those features I am creating, so I am running that function. So here you can see the train aggregation features df. Once this function is done, right, here for each id, here you can see the downtime mean, downtime standard deviation, downtime minimum. So each feature, okay, here we are creating aggregation level features. Same features I will create for the test df also. Okay, so this is the test df features. So here you can check the train aggregation features df dot shape and test aggregation features df dot shape. Okay, so 46 features extra we created. Okay, next we'll merge with the what are features, publicly available features, right. So here train features, so merging whatever features we created on id and how is like left. Okay, same we are doing for the train and test. Okay, at the end, what are the shapes we have? For training we are created public plus whatever features we have created here is like 275, and also test data also same features 275. Okay, now we need to merge our target variable. Okay, our target variable is like train scores, right. So we have to merge to the train features df. Okay, so here I am merging train scores to the train features df. So now if you print this train features, so at the end it will show you the scores. Okay, this is the scores for each id we have. Okay, if you see the test, same for the test, you don't found any scores, so we need to predict for the test data. Okay, in test data we need to predict and assign new column to test as a scores and submit to the competition. Okay, next we'll try to create one baseline model. Okay, so here we need to mention what are the train columns. Okay, so what are the train columns? So in our df, what are the train column is the score, and the drop columns is id. We don't want to use id in training data, right. So we are dropping the training id. Remaining what are the except target and drop columns, remaining all are the train columns. Okay, so if you check this one, so we are having 274 train columns. Okay, one target column. Next we'll create base model based on the k-fold. So here mention the k-fold object. So k-fold cross validation, here op validations prediction to save the out of fold validations. And here what are the test features? Out of test features, what are the training columns? That test df I'm taking as a x test, and what are the predictions after getting each model prediction I'm saving is the test prediction list. Okay, so here I'm iterating through the each fold. We are creating 5 folds, right? For each fold from train, just I'm creating x train, y train, and x valid, y valid. This x train and y train is used to give to the model, and this x valid and y valid is used to evaluate our model. Here I'm printing the shapes of that dataset. Then we are using light GBM regressor. Okay, this is the base model we can go with. So here we are providing the regression. So this is the regression. We are predicting continuous values, right? 0.5 to 6. So I'm mentioning objective as a regression, and metric we are using root mean square, RMSE, and number of estimators I'm mentioning as a 10k estimators, and boosting type I'm mentioning as a gradient boosting GBDT, and also seed I'm passing as a 42. So I'm passing to the light GBM regressor. So here I'm mentioning the early stopping to not overfitting on the training data. Okay, so I'm using validation data to early stop routes are 200, and verbose for every 100 iterations I need to see what is the scores. Okay, then I'm using model.fit, same like SQL and model fit. So here I'm passing x train, y train to the training data, and evaluation set I'm passing x validation, y validation to evaluate our model, and the callbacks I'm passing early stopping callback and verbose. So printing after number of iterations what is the scores. And here once the model is trained, right, once we have the best model, so we are predicting on the x validation. Okay, so in x validation whatever predictions, right, validation index, that particular index we are saving into the out of validation predictions to get the out of fold predictions at the end. And also for each model I am predicting x test. Okay, for testing data I'm predicting the test predictions, and saving for each fold I'm saving into the test prediction list what we are mentioned before for loop, right? Once we have the validation predictions from the model, right, based on the validation predictions, and y valid, true validation labels, true validation targets we have. So here I'm using scalar metric function. So mean squared error, so squared equal to false, it will return the root mean squared error. Okay, at the end, so once your loop is done, right, so here I'm calculating out of fold based on out of validated predictions what for each fold we are assigned to this particular array based on the validation index, right? Once we have that, right, we can calculate the out of fold out of fold scores. So those are the out of fold scores that's printing. Okay, once we have this function, right, we can run this. So it will run for the fold one in training data we have this many samples, and the test validation data this many samples. So it's trained based on this training data. This validation data is to early stopping. It's for each 100 steps printing what is the root mean squared error for that particular iterations. Okay, so at the end for fold RMSE scores, right, for this fold we are getting 0.59 score, and here you can see for each fold we are getting similar scores. So at the end out of fold score validation, all the validation sets what are the scores. So all the validation we are getting 0.65 as a root mean squared error. So this is like simple model, right? We are getting this much of score, validation score 0.65. Okay, so if you see the test prediction list for each fold, for 5 models we run, right, for each model we predicted for the test data. Okay, so we run the 5 models, right? So here we have in the 5 test predictions: fold 1 prediction, fold 2, fold 3, fold 4. So those 5 folds prediction we have, so we have to average based on the axis 0 here. So we need to get average, right? So here I'm using np.min, so test predictions list I'm passing and axis as a 0. So here this all the folds prediction averaging based on the axis 0. Now here you can see we get for 3 samples we get 3 predictions based on the mean of those 5 folds, okay, based on the axis 0. Once we have that, right, we directly assign to the test features scores. So here creating one new column scores, and we are assigning those prediction, whatever predictions we get, and after aggregating throughout the axis 0, and those predictions we are passing to the assigning to the test features scores. Okay, here now here you can see before we don't have the test features scores, right? Now we predicted that scores, and in test data they provided 3 sample IDs, right? For those 3 sample IDs we predicted the scores from the model. Once we have, right, so we need to submit to the competition. So this is the sample submission they provided. They want to submit like ID and score as a sample submission. So we have test features df, right? Test features df will select ID, and what is the predictions here, score is the predictions we predicted, and using .csv, so we'll save that as a submission.csv, and will pass index equal to false. Okay, it will save in this notebook. So here you can see the output, right? In output section, this is the submission file which saved. Okay, this is the base model, right? To improve this model, so we need to found some hyperparameters. So we'll do some hyperparameter tuning now. Here we'll do the hyperparameter tuning based on the OpQ now. Okay, here is the code. So for those are the hyperparameters for the light GBM. So here we are telling to the OpQ to search in between those parameters and get the best hyperparameters. Okay, here we are saying OpQ create study. So our objective here is to minimize the root mean squared error, right? So we are passing optimization function as a minimize, and we are passing as an objective. So it will take the trial as an input, and we are running this for 5 trials. So you can, if you want more robust model, right, so you can mention this is the 100, 200, something like that. So it will run for the 5 trials, and in 5 trials what is the best parameters we found. So here we are just running for the 5 trials. So what are the best trials and what are the best hyperparameters in between it found. Once you have the best parameters, right, we can pass those best parameters here. So I am already taking this best hyperparameters from the public notebook. So here I'm mentioning as a 10 folds. Here we are giving more training data and less validation data to train our model for the 10 folds. Okay, for each fold again we are saving the x predictions in a x test predictions list. Okay, it will run for the 10 folds. Here you can see it's running for the 10 folds. Okay, once it's run for the 10 folds, you can see out of fold scores. So here you can see 0.63. okay, before from the base model what you get is like 0.65. this is slight improvement. Once we were doing hyperparameter tuning, we got some improvement, right? So we'll submit this model to the competition. Okay, so if you want to check what are the important features out of this model, right, you can use this function. You will get the important features. So here using this function, this plot, you can see what are the important features for this models. Okay, here you can see the input word length mean is the one of the important features to identify target score. Okay, here you can see other parameters, what are the important features. So next we have test predictions list, right? For 10 folds we have, so we are assigning into the test features as a scores. Okay, so once we assign that, we have to save id and scores, right? So here is the id and scores, we are saving as a submission.csv. okay, once we have submission.csv, right, one thing you have to remember here, right? So while we are submitting to the competition, so always turn off your internet. So if you go to this tab right here, you can see the turn off internet is on, but you have to off this internet. So then you have to save this notebook. If you click on the save version, right, here this version is rerun. So once you click the save version, right, if you click on this, it will show it's still running. It will rerun whatever whatever models you are running, right, that will rerun from the starting to the end. So if you click on here, right, so open in view, it will show the logs while running. Okay, so here it's showing the running logs. What are the running logs? Once your notebook is run successfully, here you can see what are the versions you are run. Okay, I'm taking the latest version. Okay, this is the output, whatever notebook you are run, right, it's rerun. So it's rerun, and it will show you what are the models you are using and all. So at the end we are saving sample submission file, right? So we need to submit this notebook to the competition to get the scores. Okay, so to submit this notebook to the competition, you have to go to the output, right? In output tab you can see submission.csv. okay, you have to save it as a submission.csv. so here you can see what are the predictions you predicted, what are the IDs we have, right? Next, if you want to submit this to the competition, you have to click on the submit. Okay, once you submit to the competition, it here you can see what is the notebook we are selecting, what is the version, this is the versions 2, and also what is the submission output file you want to submit to the competition. So submission.csv, and here you can give some description, whatever the description, this is optional. For example, base model I am giving. So here you can see in this competition we will privately rerun your selected notebook version with a hidden test set. Okay, they are rerunning this notebook version hidden test set, so they are having hidden test set. So this notebook will rerun based on that hidden test set. So once you submit this model, here you can see in this competition we will privately rerun your selected notebook version. This will run on the hidden test set. Okay, so they are having some hidden test set to prevent the overfitting on test set. So they are not disclosed the test set yet. So they will rerun your whatever models you run this notebook, right? They rerun in privately and predict on the test set, and after predicting on the test set, it will give the output file as a submission.csv. okay, here we have in publicly available only we have three IDs. In privately they have many IDs that we have to keep in mind. So it will run in their end and will give to the scores based on that. Once we have this, you can just click on the submit button. It will submit to the competition. Okay, competition submissions tab, you can see once you go to the competition, go to the submissions tab, here you can see it's rerunning in their private environment. Okay, same environment but privately they are having hidden test set. It will run both training data and predict on the test set whatever they are having. Once this is completed, running completed, right, you will get a public score as like this 0.601. So you if you go to the leaderboard positions, so here I am in the 70th position. So this is the bronze medal I'm getting, okay, from that submission. So we are simply bidding publicly available notebook. These medals are not finalized. So here you can see they are using 50% of test set to calculate this notebook. Okay, the final strategies will be different. They are using another 50% of test set to calculate the private leaderboard. Okay, again you have 2 more months to go, so you can try your models, different types of models, ensembling and all those, and create new features. If you have any questions regarding competitions, you can ask here. And if you want to learn more from the others public notebook, you can select whatever notebook you want here. So then learn from those notebooks and try to improve your solution. Next 2 months you will, this is like very simple competition compared to other Kaggle competition going on. If you put some hard work and do some model training and all those, you will definitely get some medal. Okay, this is easy competition. If you want medal, so this is the one of the easiest competition I saw in last 1 year. Okay, so you will get medal easily. To get that medal, you have to continuously improve your model, learn from the other solutions, and at the end you have to do ensembling and trust your out of fold cross validation. Okay, those are my tips to improve and succeed in this competition. So if you like this video, please click on the like button and subscribe to this channel. In future I will try to upload more competition solutions, and also you can recommend what I need to do in next video. So I will work on that competition and try to beat public solutions. I will provide you the base solution for that competition now. So you can directly mention in the comment section, and also you can contact me in LinkedIn also if you have any doubts. Please subscribe to my channel, so it's motivating me to do more videos on those. Thank you.